Hello, everyone, again, and thanks for joining us for our last webinar of 2020. My name is Lisa Shaw, and I'm the Marketing Automation Specialist at SICK. SICK is a leading provider of sensor solutions. Today, Saurabh Banerjee, a Market Product Manager for Software and Systems at SICK, will be talking about the simple steps to implementing deep learning technology. And he will be providing some insights on how to successfully implement deep learning machine vision to enhance your applications by using SICK's industrial-grade smart cameras embedded with deep learning software. Just a little housekeeping, and before we get started, I would like to share that if you have any questions throughout the presentation, please type them into the Q&A box in your control panel. It's usually on the right-hand side at the bottom. We'll take some time at the end of the presentation to address as many questions as time allows. Also, a recording of this webinar will be emailed to you following today's presentation. Now, without further ado, I'll turn our time over to our presenter. Saurabh, please take it away.
Thanks, Lisa. Happy Thursday, everyone. Hope you had a great week. Today, thank you for joining us for our deep learning session. This is actually our second deep learning webinar this year, and deep learning is a hot topic. And the reason for doing this webinar is deep learning is often seen to be something that is very complicated, and also it's not something that's common in the industrial space. We at SICK are some of the primary adopters of deep learning, and now we've been using that deep learning in our SICK systems for some time now. But recently, we have made deep learning as a software product. So the idea of this webinar is to show you or uncover some of the myths that's using deep learning, get an introduction of exactly what deep learning is all about, and see how in SICK we are using deep learning to solve some of the machine vision solutions. Okay. So just a quick introduction for those of you who don't know SICK. SICK is a global sensing and automation company. And the name, some of you might ask the question, is a bit unique. It's actually named after our founder, Dr. Erwin Sick. As you can see, SICK has been around for well over 70+ years with over 10,000 employees and 50 subsidiaries and close to $2 billion in global sales revenue. Here in the United States, SICK is actually headquartered in Minneapolis, in our Bloomington office in Minneapolis. So SICK, we do multiple different sensing technologies. We have over 40,000 product portfolios, and it can range from anywhere from a simple, tiny photoelectric sensor to do detections, all the way to complex vision systems, along with LiDAR, as well as RFID systems. We also do and are very well known for our safety systems as well. For example, light curtains, and then on the higher end side, we also do a lot of the edge devices and control architecture solutions as well. And what today we'll discuss is combining some of our edge devices as well as some of our software solutions and our machine vision portfolio to uncover the deep learning and use deep learning to solve some of the machine vision applications. So what exactly is deep learning? So I have heard many people use deep learning and artificial intelligence interchangeably. So deep learning is not artificial intelligence, but it is a subset of artificial intelligence. Artificial intelligence is a very generic term that is used to define any technique that helps machines learn or solve problems like human beings. Machine learning is another subset of artificial intelligence that uses the technique of statistical methods to analyze data, learn from the data, and then predict some results or make any other predictions. Deep learning is another subset that uses a different technique, and this technique is called the neural network technique or a neural modeling technique in order to actually analyze the data and then make the predictions. So the question comes in, what exactly is this neural network and why is the name deep learning? So in order to understand the deep learning and neural networks, you need to understand deep learning is basically used to mimic the way a machine learns, just like how a human brain learns. So if you look at the human brain, it has multiple different neurons, and these neurons are constantly making different decisions that are influencing different outputs based on different criteria, different statistics, different time of the day, and it's all happening very fast. Deep learning is something similar, where you basically have, at a very high level, when you have just one network that's making a decision, you basically call it an artificial neural network, or ANN, where it is a one-layer deep network. So usually, the crux of it, every deep learning is comprised of, at the minimum, 3 layers, where one is the first layer, which is the input layer. That's where the decisions are to be made, the inputs are provided. The second layer is basically one hidden layer. So that's when the decisions are being analyzed, or the inputs are being analyzed in order to make a decision. And number 3 is an output layer, where the decisions finally become an action or an outcome. So if you have multiple of these hidden layers between your input and the output, very simply, you're adding more deeper and deeper layers, and that's how the deep learning name comes in. For example, I'll give you a very personal example or a generic example to make a decision, how humans make a decision, right? Let's say you're walking down the street and you get a smell of food, right? You're passing by this famous pizza restaurant and you get the smell of this pizza. So that smell is what is part of the input layer, and that's input to your brain. And your neurons are suddenly, excited about this pizza smell. Your neurons have hidden layers that basically tells you that, yes, you do love pizza. That's why you want to, take some actions based on this input. The actions could be different. Either you go and have a pizza or you ignore that pizza. So that actions will be determined based on other neural factors, which might be the second or the third layer of decision making, whether number 1 is whether you actually have, the appetite for the pizza, whether you're actually choosing to, have a pizza depending on how, you're leading your life, right? So, and all of these then comes into making this decision that then goes into your output layer. And all of this is done as a fraction of a second, right? But in order to make that from the first smell, which is the input, to making that decision, there might be, many multiple layers that's hidden in your brain. And we are trying to mimic that same thing in a machine environment as well, using our software. So why deep learning in machine vision? Machine vision has been existing for a long period of time. It's a well-trusted process. So why is the need of this deep learning? Here I have an example, and this example is based on solder inspection in electronics. And this is very key because in this solder inspection, it's very difficult to actually inspect if the solder is making a good contact or a bad contact. There could be multiple different outcomes. The solder could be a good contact, it could be no contact, it could be a bad contact, it could be no contact with some dirt, it could be a short circuit, or it could be a short circuit with contact. So as you can see, there are so many different complexities and different outcomes. It actually makes it complex in order to solve this using just a machine vision or traditional machine vision. So deep learning, and so the question comes in, how in these kind of applications, how do you reliably detect the defective path? How are you able to distinguish between these different paths? And actually, can you actually automate this process, or is there the failure rate is so high that you actually need somebody like a manual intervention in this process? So we will see that deep learning actually will help you to solve this application. So there are two stark characteristics, or I would say there are multiple characteristics, but the main characteristic that differentiates or creates an advantage for deep learning is in traditional machine vision. There is this step where you have to actually manually extract the features based on the object that you're trying to detect in order to come with a reliable machine vision inspection applications or any detection application. This manual feature could be, the characteristic of that object itself, the length, the height, the pixel size, etc. This creates a lot of complexity, and it usually requires a person with an expert vision knowledge in order to carry this step out. Whereas in deep learning, this entire process becomes an automated feature extraction based on what we call as an example-based learning. So this relates to the two basic differences. One is in the traditional is the rule-based learning, where in rule-based learning, you as a machine vision expert are trying to define some predictable features of that object before you start doing the inspection. These features need to be well-defined, they need to be predictable, and if it's a complex object, it makes even more complexity. For example, let's take a food example, right? Let's take you're detecting an apple. Yeah, you can definitely, create some tolerance limit, some length, width of that apple. That's great. Let's say in that same line, you might have strawberries, or you might have pears, or you might have oranges. If it matches within that same, the same characteristics, now your machine, your vision element is confused, right? Because it can't detect and distinguish between these features. Some of the examples, though, traditional machine vision can be used, and it will continue to be used, are, for like barcoding, measurements, and object, where there is a clear definition of the tolerances and clear definition of these characteristics. Whereas in example-based learning, instead of teaching the vision cameras on the characteristics, you basically teach them by showing pictures or showing images or showing an example. So this is how an apple would look like. So you actually do some training of the camera by showing them different varieties of apples, different, in different orientations, in different colors. Similarly, you do it with different fruits. And when you do those kinds of supervised trainings, you create this neural model that then becomes so robust, then it creates a confidence matrix where in an unsupervised learning method, it can easily predict and distinguish between these different objects. So in this case, deep learning is a highly advantageous because now you can use it in order to distinguish between complex objects, between unpredictable objects, objects that change, deforms like a plastic object within a production scale, and you can do this quality inspection much reliably. So in order to understand deep learning, you need to understand there are multiple different application domains where deep learning can pertain. Number one is called as classification, or in deep learning, it's called advanced classification. Just like the name suggests, classification is basically you're classifying or you're assigning an object to a predefined category. And the question that you're asking is, what class does this image or this complete image belong to? could be a box, it could be a bag, it could be a fruit, it could be a defective good, it could be good, bad, etc. The next stage is actually anomaly detection. Anomaly detection, just like the name suggests, once you present an image, the algorithm analyzes the images, and it basically has a gold standard, and it compares with the gold standard and looks for any anomalies within that image. The question that you're asking now is, does the object in the image contains any anomalies, and where it contains? So there is a piece of localization element as well. Then comes the segmentation. This is the most advanced level of deep learning, which is segmentation and detection. In detection, basically you're asking a question, if you have multiple different objects that are in multiple different classes that has been classified, and you're looking for a certain object that could be amongst in multiple different classes, you're asking the question, where in these objects, in these different classes, a certain object might be located. For example, in this conveyor system, you have multiple different boxes, and some boxes might have ribbons. So might be you are searching for a certain type of ribbon. Might be you're looking for a label, a certain type of, let's say, a hazard label. So where in these three boxes is there a hazard present? And then you are able to also do segmentation, where basically each and every pixel of an image is then classified in predefined category, and then you're asking the question about which pixel belongs to which class. Segmentation is actually the application domain that's used in automating, automating driving, right? So driverless cars, they have either a LiDAR or a camera base, and they're able to take in that entire image and segment between a road versus a human being versus a footpath versus a light. So these are the multiple different application domains that deep learning involves. We in SICK actually, we have solutions in all these in different capacities, in different applications. But today what we are going to focus is on the classification and the advanced classification model. So classification, basically, as I mentioned, it is you have an input and you're training that input, you have a classification, and then you have an output. And when you classify this in deep learning, there are basically 5 steps. So number one is basically the data ingestion. That means your data input, you're gathering the data. This could be done using a 2D device, and this 2D device could be just a mono device or a color device. We could do using a 3D heat map. We don't do the point cloud today yet, but it's under development. The heat map is also, we could do it, but it's in a preliminary stages. But what we currently do most is the 2D detection. That's our main focus here. Once we have the data, we now define that data. What that means is that each of these data might fall under different classes. We put a label to that data that basically identifies into these different class models. Once that is done, then you actually select what level of classification you need. Like I mentioned, once you add a layer, you're deepening the deep learning layer. So you're adding another neural network, So we then, and this is where our vision experts and our application experts comes in, because not everything you need is a very deep neural network model. You can, satisfy, you can actually solve an application using a small, medium classification as well. So but this is where we do the training, we select the model, and then the 4th step is actually we are doing the training and evaluation of these images in order to give a confidence matrix based on where the software tells it can confidently differentiate and determine what exactly each of the object is. And then we train, after we train it, we also evaluate it using some untrained images so that we can qualify the training. And once that is done, we then deploy this. This can be deployed using our edge device, which is a SIM, a sensor integration machine, but we're also preparing to have this directly loaded onto a camera, which will be our Inspector P camera as well. The model that we are using, the technique that we are using in this advanced classification is called the CNN, which is a convolutional neural network. As the name suggests, convolutional means, it is a multi-layered neural network that basically, recognizes different patterns within the images that you are supplying and thereby come to a conclusion. So in this example, if I have multiple different nuts in this example of 16 by 16 pixel image, I can break, one neural layer might break that 16 by 16 into a 2 by 2. It then breaks it down into a 0.5 by 0.5 pixels, basically then to analyze each and every layer to come out and distinguish between different types of lines and intersections. It could be, a slanting line, it could be a T, it could be a cross, but breaking this down into these multiple sub-pixels allows us to create the robustness in order to identify each object accurately. Here's another example what happens during training. And actually, I'm taking this example to do like an optical character recognition. This is a very useful tool of optical character recognition. If you're trying to read date codes in your packaging labels or DPM marks on your parts, and you're trying to identify exactly if the right characters were printed, or you're trying to verify if the right characters were actually on the label. So we actually use a deep learning algorithm within our software in order to actually come to that conclusion if the correct text, and in order to identify that text. So here I'm showing in the middle is this deep learning, this neural network. Think of each of those blue dots to be one of the nodes, and each of them basically what it's doing is it's solving a puzzle. Or an equation in mathematical terms. Let's say it's y is equal to ax plus b, where y basically is an output and x is your input. And we at a and b are different weightages. And we will basically, while we do the training, we basically change these weightages. So what happens is first the camera looks at this image and it has these multiple different pixels. Each of these pixels are then converted into equations that are then fed into these neural nodes. These neural nodes are then solving that equations and coming up with a result. And this result in your first pass might be like this, right? So now we take that result and we evaluate it, and then we see if it's the right result or not. As you can see right now, the confidence level is nowhere. It's pretty poor. So we then retrain the entire network, and basically we keep adjusting the weightages until and unless we find a good confidence score that says that, yeah, this software model is actually being able to evaluate the image and seeing the number 4. Once that is done, then what and this is the step that is called as the supervised learning. And this is a step that is required in every deep learning model. And once the supervised level is done, then what we do is we then introduce some more different numbers like 5, 6, or even 4 in different format, in different pixel size. The goal is to basically make sure that the software maintains that confidence level. So what are we doing today at SICK? Like I said, right, there are 5 stages, right? Number 1, we need to collect data sets. So, and this is very crucial your deep learning neural network model will be as good as your data sets, right? So we need to collect some good amount of data sets, and this data sets based on images needs to be in an operational environment, because every time you change the operational environment, the feature set, the details might change that might lead to different levels of confidence. We need to collect both good as well as bad images. And we need to make sure that we have, multiple different variables, whatever, your predictable outcome you could think of, right? Once that is done, then you do the classification, which is labeling. Once the labeling is done, now you're actually doing the training, which is step 3. Once the training is done, you analyze the performance. Once you're happy with the performance, you either deploy. If you're not happy, then you retrain, right? Now, the step number 3, I put that in red because that is the step which is most time consuming, as well as it is very expensive, so it requires some infrastructure. Because that is the step where you're actually solving the equations based on these hundreds of images that you might have collected. In some cases, it might be more, some cases might be less. But nevertheless, you need to make sure that you have a solid, robust algorithm that is able to solve these equations fast. Number 2 is that, so what that means is that you need to, have, good software engineers, good deep learning experts in order to, select the right algorithm and deploy the right algorithm. Number 2 is that you need to have a good, processor in place. So this processor has to be a high-speed processor. So that is basically, the most expensive part, where it is able to handle all of these multiple equations and solve it to you. So what we are doing at SICK is we are taking that step number 3 out of your expenses and out of and we are giving you and we are providing that as a service to you. So we already have some industry experts with deep learning. What we have done is we have now actually created a software tool that basically helps to analyze that data and provides you that training set. So in our step, all you do is you collect the images. It could be using any standard camera. The ideal is to actually collect the images using the same camera that you would actually deploy the neural network on. So it could be our Inspector P camera, or it could be just some of our Pico or MIDI cams that are standard cameras that you connect with our edge device. So you just collect those images, different set of images. You send those images to us. What we do is we run and we use this the software tool called DStudio. We run this software tool to actually analyze the images and come up with a confidence matrix, and then we provide you with a trained neural network. This neural network is free for you to then download, implement on your device to basically evaluate and see if it works. If it doesn't, then we train it again. But we do all of that step, and we offer that as a service. So this training is then done, and then you can then implement this neural network model using a SIM. Like I mentioned, it's an edge device, and the SIM device, you can connect some of the standard Pico or MIDI cams. We offer both mono as well as with color, and then you can do the inference directly. The other one that we will soon launch is an Inspector P camera, where basically it's a smart camera. It has a processor in it, so now you can actually load the neural network on this Inspector P device as well. So I also mentioned that the deep learning is going to be part of our app space engine. So app space basically is our engineering framework that allows users to deploy and develop their own applications for some of our programmable devices. So deep learning is going to be part of that API as well in app version 2.11.1. So now you can develop your own, your own classification models, your own neural network models, and then call upon the deep learning API as well. The applications I already mentioned, one is the solder application. It's very common, and deep learning is now, is going to become the preferred way to solve that applications. But, the same thing you can apply in an automotive inspection line for looking for missing parts. We did one application with the wood industry where we are looking at the shapes of the rings shape of the wood. So this helps the wood industry in order to determine good versus bad or how to classify and sort them. In the food and beverage industry, this is another difficult application where there might be multiple different, like this cracker or this biscuit being cracked, right? It might all have the same characteristics. It might be within the tolerances, but actually the cracked biscuit might be is a defective part. So with the deep learning image base, you are able to identify that. We are actually doing an application where we are actually determining some foreign objects within some food applications. So that is another thing where foreign objects could come in different shapes, sizes, colors, where in machine vision, traditional machine vision, it becomes challenging. So we're using the deep learning in order to identify that. But there are other multiple different applications where deep learning can be used. This is the solution that I mentioned. It's the label checker solution. The label checker is one of the first products within SICK to utilize deep learning. The label checker, as the name suggests, it checks anything that's within a label. It checks date codes, it checks the label size, it reads the labels. But what it is known for is optical OCR, so optical character recognition and optical character verification. And the way we are segmenting and teaching each of these characters are using predefined deep learning models and training sets. And this way, we are actually able to offer a much better OCR in the market, an OCR tool in the market. All of this, again, is powered by our SICK app space. So deep learning tomorrow, like I said, right now we are offering deep learning as a service where we take on the burden of training the data sets. We collect the images for you. We train the data. We give you the neural network and you deploy it. In the coming months, the tools that we are actually using to train that model, we are going to make that tool into a software product. And this software product is going to be a cloud-based software tool that you as a customer can directly access it. So what happens is that now you can access this on your own time. You can collect the images. You can upload the images onto the software tool on this cloud. And you can do your own classification, and you can let the training run. Depends on the size of the images, the product data set. It might take 15 minutes to half an hour, and depending on the level of neural networks you need, then what will happen is you will be able to get your own neural network model. So in this case, you create your own data set, you run your own classifications, and then you get a neural network model where you can then evaluate the result of the neural network by loading it back onto your camera in your production environment, and you see how your training network works. And this is all done for free, right? So the software is for free. It's a cloud-based software. The only thing is, because of security, we request you to have a SICK login ID so that everybody has their own access levels. And then the neural network that you can then download is also for free. This is like a trial neural network that allows you to actually test it out. And then if you're satisfied, and when you're satisfied, then you can actually go in and purchase the neural network. That would be like a one-time purchase that you can then deploy on multiple different devices for that neural network. And if you have multiple different neural networks, then you just purchase the different neural networks models as well. So again, this will depend on your production usage. So this is some of the codes from the neural network. It gives you that confidence matrix, and it allows you to then see what the confidence level of the neural network model is. Our next stage is right now, as I said, we are planning to use the edge device, the SIM 1012, and connecting to some Pico and Medicams to run the deep learning. Our next focus is to actually have an Inspector P version. So Inspector P, there's a 621 version to be enabled with this deep learning. And then slowly what we are going to do is to have all of our vision portfolio enabled with deep learning, then our edge devices portfolio to be in deep learning. And our focus next is going to be on 3D vision solutions that we have, the Trispector, the Visionary, etc. We are also creating some starter apps as well. So these starter apps, then you can download from the apps from our app cloud, so our app pool on the cloud, and you can just use that in order to do some segmentations, in order to do the pixelization. So that gives you a good starting point as well. The next would be also expanding our application domains into anomaly detection. In the next couple of months, we are going to come up with this anomaly detection, as well as have like an on-premise solution. So for those of you who might think, okay, I'm not comfortable having the images on the cloud, I need a faster solutions, and maybe I need to have it continuously running. So we are actually working on having the software being loaded on an industrial PC and having an on-premise solutions. Just so you understand, the cloud is also very secure. We follow, the state-of-the-art security standards. We encrypt all of your data, and the thing to remember is that your production line is not connected to the cloud. It's just that you're taking the images and you're uploading it to the cloud, which could be completely isolated. And once you train it and if you're satisfied, you can just delete all of the data set, and it does not reside within us. Only you have access to it. So the main advantages of using the deep learning as a service and deep learning as a cloud and our solution is, number one, the inference is actually, the training is done on the cloud, but the inference is actually being done directly on the device itself. You do not need an additional PC, which is one of the most expensive part of a deep learning. You need to invest in a very high performing PC that can cost tens of thousands of dollars. But in this case, you don't need that. You have a faster decision time because we are doing all of that using our processor on the cloud. We are able to do that quickly, and you are classifying the result as a sensing value. The training is again done on the cloud, so which means no hardware. Also, you don't need any software. You don't need training on that software. It's very, very simple and easy to use, walks you step by step. And in the end, you get a neural network that is free for you to actually use it, test it, and then if you feel like it, then you can actually get your own. And then once we have the starter app, you then will be able to also quickly deploy using the starter apps and make your own solutions based on your specific use case. With that, it comes to the end of the presentation. We're right at 10:40, so we do have 20 minutes. So if you do have any questions, please let me know. And if you do have any applications, please feel to reach out to us. So I will now open it up to any questions.
Thank you, Saurabh. Yes, if you have any questions, please type them into the Q&A box. So the first question is the network size based on the number of images?
That's a good question. So the network size, it's not based on the number of images, but the network size is based on the details of the images that you have. So if you have, let's say you have an image of a dog and the background is of a cloud, right? You might have, sometimes the neural network might be looking at the background in order to determine if it's a dog versus a cat, if the cat has a different background. So it depends on the details of each of those individual pixels and individual detail of that images that needs to get deciphered. So that's why I said it's always better to start with a small neural network. More often than not, you are able to come to a conclusion with a small neural network and then move on from there.
Awesome. Freddie asks, what is the average training time required?
So the training time, again, it will depend on the number of data sets and number of classifications. For example, if you are having, let's say, if your application is just good and bad, right? You're having 2 levels of classification, and each of them, let's say, has 100 images each. Using a small intensity classification, you should be able to get a 95% upwards confidence level within 15 minutes. But in a real scenario, you might need multiple different classifications where you're basically trying to classify between different types of nuts, different types of food, different, you might have 5 different levels of classifications or 6 levels of classification, and each levels of classification might have thousands of images. So depending on that, the process will take time. But the good thing is, because it's in a cloud environment, you don't have to wait for it. You don't have to sit and wait for the software to train. You upload it, you start the training process, and let's say it takes 45 minutes, let's say it takes an hour, maybe 2 hours, depending on the size of the images. You just, go on with your day, right? Get a cup of coffee, go on with your day, or, let it run overnight. And the next day you might even come up with a confidence matrix. So it really depends on the image size, the number of images, and the number of classification layers that you may have.
Awesome. Can we use this for vehicle classification or car number plate recognition?
That's a good question. Currently, you could use it for vehicle recognitions as long as you have, you're able to capture those images. So our camera right now is more, like I said, it's an Inspector P and a Pico and MIDI-cam. We have not done this application, but definitely if you have, we can train that data set, and absolutely you can then be using it. The good way to use the vehicle classification, instead of using the normal classification, I would use segmentation, because that way it can actually determine where exactly the number plates are, if there are some changes, if they are looking at multiple different cars coming in. That would be a much more advanced level of classification, which we currently have in a very limited set. It's not for that vehicle. But yeah, that is also something that we can use it for.
Great. Does deep learning apply to older versions of SICK sensors?
That's a great question. No, it does not. Right now, we have some special devices in the SIM 1012, as well as we'll come up with an Inspector P. These are special devices currently, new devices that implements the 2.11.1 and has a deep learning license enabled on it. Once we actually standardize the software, as well as have all of the devices, come up to deep learning, then you would be, you won't be able to do backward, you would only be doing the forward going. However, if you're using, like, say, a picocam or a midicam, right? So you don't have to change the pico or midicam. It could be the older version, because now the inference is not being done on the camera, but it is being done on an edge device or a controller. So as long as you have the up-to-date controller or the special SIM deep learning enabled controller, then you can still use that same camera to collect the images and then make the decisions on this controller.
Awesome. Another question is, some products or images have a corporate product sharing limitations. Does SICK accept NDAs?
We do accept NDAs, absolutely. Some of the applications we worked with, we do have NDAs. That is a case-by-case. Yeah, we are open to doing that. It is a case-by-case solution. So if you have further questions on that, please let us know. But yeah, we have done, multiple level of, NDAs that are in place already with some of the global corporations in food and beverage, automotive, as well as in the semiconductor industry.
One question came in is asking if there will be a recording of this available afterwards, and the answer is yes. I will send out the recording of this presentation, and I'll email it to you by tomorrow. Saurabh, another question is for you is, do you use Python or R language while programming?
This is a good question. It's right now it's with AppSpace, and AppSpace is none of those. It's a proprietary for the deep learning. It's a proprietary language. We use some combinations of different tools as well as our proprietary tool in there. And for AppSpace development, we use the script called the Lua script or the Lua language, which is, it is similar to Python, but it is a more lightweight language that is used in embedded devices, especially like in the gaming industry. They use this Lua programming because it makes, it has less overhead.
Awesome. Those are all the questions I see. There has been some questions that are pretty specific that I'll have Saurabh reach out to individually different attendees. But if you have any questions, you can see Saurabh's email address on the screen. Feel free to reach out to him. And Saurabh, is there anything you'd like to say before we wrap this up?
Well, thank you again. As Lisa mentioned, this is our, the last webinar for 2020. I'm very happy that this was with deep learning. One thing is certain is that deep learning is going to make machine vision as well as other applications much more simple. Deep learning is a growing industry trend. This decade of 2020s is going to be all about deep learning. So this is the, the right time to investigate your current processes to see that maybe you can actually make it much more efficient using deep learning. Traditional machine vision will still stay, but there will definitely be some other processes that deep learning can help you solve, especially using services like how we are doing in SICK, where we are taking in that burden to actually solve those equations, and we have made all of the investments necessary for that infrastructure. So that takes a lot of those investments out of the customer's hand. But again, thank you so much for your time.
Yes, thank you, Saurabh. Thank you to all that attended. And as Saurabh mentioned, this is our last webinar of 2020, but we have a whole list of lineup of new webinars for 2021. So we'll keep you updated on those upcoming webinars. But have a great holiday, and thanks again.
Yep, thanks everyone. Have a happy holiday. Thanks, Lisa.